Welcome to sublesson 8.3 where we'll configure DNS on a Linux system. So on a Linux system, we use DNS to resolve remote host names. The first thing to know about is how to configure the client side, how to do a lookup, how to point to a different DNS server and examine those configurations. So there's a few places to look. First, there's the etc hosts file. Let's take a look at that. etc hosts. So this looks like a pretty boring host file. What we show is the IP address 127.0.0.1, this is our loopback interface as we learned in the last sublesson, is configured to be the hostname localhost and the domain localhost.localdomain. So this is how I can say ping localhost and it knows who to talk to. It uses the host file to translate the term localhost into 127.0.0.1. So that's pretty boring. Let's see if we can make a change there. I'm going to edit my host file, and I'm going to put another entry in here. I'm going to say 127.0.0.2. So all of the 127 address space is reserved just for local loopback. I can do whatever I would like with it, and I'll just call this, say, live lesson. And I'll go ahead and quit. Now if I ping live lesson, the Linux system knows who I'm talking about. It knows I'm talking about 127.0.0.2. But you can see that this method doesn't really scale very well. You couldn't possibly add all of the internet hosts to this big host file. It just wouldn't work. So instead, that's what the DNS system is for automatically resolving those through a server. Those servers are configured in etc resolve.conf without the E. Notice that, resolve without the E.conf. As we learned before, my Vagrant box here is configured to be a DHCP client. So DHCP is automatically configuring the name server for us. So this is telling me that 10.0.2.3, this IP address, is configured to be my DNS server. When I try something like ping google.com, first we look up the IP address against our DNS server, and then we start pinging it. We translate google.com into an IP address, and it starts sending pings, which we'll learn about in just a few minutes. So we can change our DNS server really easily. We can edit that file, resolve.conf, and I could put a comment here if I wanted, so I just want to save that. I don't really want to change it, or I don't want to lose it. And I could say name server, and I'll just use another name server. A public name server that's available is Google's name service 8.8.8.8, or we could copy that and say 8.8.4.4. These are name servers that Google makes available just for public use. And now, if I ping google.com, I'm no longer looking up against 10.0.2.3. I'm using 8.8.8.8 instead. So this is how you can configure a name server manually on a Linux system. Now, how does Linux know when to use the hosts file versus when to use DNS, and what order does it go in? That's configured in another file, the nsswitch.conf file in /etc, so /etc/nsswitch.conf. And there's a lot of information on here. nsswitch talks about what order to do things in, but the one that we're really interested in right now is hosts. This line right here, hosts line. So it begins with hosts, followed by a colon, and then it says consult files, and then DNS. So this is the order. First look at the files, then look at DNS. So the first thing a Linux system does when it's trying to resolve a host name is look in the hosts file /sc/hosts. If it doesn't find the entry there, it tries against the DNS server. If it doesn't find the entry there, it gives up. Let's see if we can confuse the system. We know right now, since we did a ping google.com, it resolved to the 74.125, whatever Google's address is that was resolved from my current network. This might change, by the way. Google has a very vast and complex network. The East Coast of the United States will have different IP addresses than the West Coast. But in any case, we will go ahead and edit the etc hosts file, and let's just confuse it. Let's say 127.0.0.2 is google.com. So now if I ping google.com, my system thinks that it's 127.0.0.2 instead. This can be pretty handy sometimes, to be able to trick the computer into thinking that one site is another site. It's great for development purposes, for instance. You don't want to be editing and testing against your live site, so you go to your local hosts file and you point it at your development server so that it acts exactly like it might act in production, but you're testing against your own development server. This is a very common, pretty useful hack to use. And then on the other hand, we can try things like, well, I want to ping some name that doesn't exist, like benwhaleylivelesson.com. That doesn't exist at all. So it tells me unknown host. What it tried to do was consult the hosts file and then consult DNS, and then it just failed because it couldn't find that domain because it doesn't exist. Another useful thing to know how to do is to change the system's host name. And there's a couple things you need to change in order to change the host name. We can type sudo hostname, the hostname command. Without any arguments, it tells us what the current hostname is, but I might want to change the hostname to, say, live lesson. So I can just say sudo hostname live lesson. Now notice the hostname didn't change on our command line yet. Currently it still says localhost. In order to see that change, I need to log out with Control-D or the logout command or exit, and I'll log back in. Notice now we see that it's changed to live lesson. I can also change it in etc sysconfig, and then I look at the network file. And in here we see hostname equal localhost.localdomain. I could change it to live lesson. And now its hostname will be live lesson going forward. So anytime you need to change a hostname, you use the hostname command and you edit etc sysconfig network. Let's quickly learn how to query DNS, which is a very important tool when you're troubleshooting DNS problems. And the command that I like to use first and foremost is dig. This is a tool to query DNS. So if we take a look at our name server configuration, remember that's in resolve.com. We're still pointing at Google's name servers, 8.8.8.8 and .4.4. I can say dig google.com, and let's take a look at this output. Google has a fairly complex configuration. We can see that google.com resolves to a whole bunch of different IP addresses, and if I look them up again, I'm just going to press the up arrow and repeat the same command. Notice this number, this second number has gone down a bit from 197 to 181. This is the time to live field. This is how long that address is valid for. And so if I'm actively doing some work and repeatedly querying google.com, I might resolve this is my IP address for google.com, and that might change. This is so that Google is flexible on their back end. They can move their servers around, and not all of the clients will be impacted. If something goes wrong with one server, they can quickly just update the host. So that's a pretty simple example. What we just did is we resolved a host name to an IP address. Sometimes it's also useful to do the reverse, to resolve an IP address to a host name. And in order to do that with the dig command, you use the -x flag. So I'm going to use dig -x in the IP address. And so what this is telling me, this is returning a PTR record, a reverse lookup, and it's translating this IP address into this host name. So this is just some random host name that apparently Google uses for its network, 1e100.net. If we wanted a little more summary output, we could say dig plus short, and then we could say google.com. Notice we don't get all the same output we got here in this above example. This is telling us all sorts of information up above, like what the question was, what the answer was, how long the query took. Here, it's also, notice it's telling us what the server is. We know that because we had resolve.conf configured to use that, but it's telling us that output. Here, in the short example, all we get is the answer to our question. What does google.com resolve to? It resolves to all of these IP addresses. If we wanted some different information, say we wanted to know what Google's mail exchange or MX records were, what handles mail for google.com, we could say dig google.com MX. And here are the various MX records for google.com. And of course, we see what the order is. Google says this is the first one. Here's our ordering right here, 10, 20, 30, 40, 50. So if you're trying to deliver mail to google.com, you'd use this one first, this ASPMX. We can see text records for google.com with text. So the idea is that you can just query a specific type of DNS record by adding the type to the end of the query. If we wanted to specify a different server to use, so say I wanted to revert and query my local one that was set by default. I've changed it to Google's public server, but now I want to go back. Just for one query, I can just say the @ sign, and I could say 10.0.2.3, which is what it was configured to do by default, google.com. Now I get mostly the same output here, but notice the server field is different. So now it's querying a different DNS server. In this way, you can query against DNS servers that your system is not configured to use by default. Sometimes it's useful because you can have different views of the world from different DNS servers, especially if things are out of sync or if there's some problem. Just a couple quick additional tools. You can use the NSLOOKUP command, which is a deprecated command. It's still around, but dig is far more powerful. Here I get dropped to a subshell, indicated by this little arrow, and I could say google.com, and it gives me much the same information. It tells me what the server is, and it tells me a number of different A records here. It's just kind of a different layout. Or I could alternatively use the host command, hostgoogle.com, and it tells me a lot of the same information as well. It shows me all the addresses, it shows me an IPv6 address, and it shows me the mail exchangers. So that's the quick and dirty on how to query DNS, the DNS client side of a Linux system.